morning students. Today I will be explaining you about DC circuit theorems. So there are so many circuit theorems available, out of which these four are very main important theorems. The first one is Theorems theorem, then the second one Norton's theorem, the third one is maximum power transfer theorem, and the fourth one is superposition theorem. So first we will see about Theorems theorem. If this theorem states about any complex two-terminal circuit can be replaced with a simple circuit which consists of a Thevenin's voltage VTH in series with a Thevenin's resistance RTH. So that's the advantage of Thevenin's theorem. Any complex circuit, it could contain any n number of sources and n number of resistances. That can be simplified into a very simple theorem, circuit which consists of a voltage source in series with resistance. So we will see what are the steps involved in Thevenin's theorem. The first one is any circuit, any two-terminal circuit. So the terminals named as A and B. So this can be replaced with Thevenin's circuit which consists of VTH, which is Thevenin's voltage in series with Thevenin's resistance RTH. So how to solve this? You have four steps. Step 1. The first thing is you need to find the value of VTH. So VTH can be found out by opening the load. Opening the load resistance RL to find VTH. After you find VTH, you need to find the value of RTH. This can be found out by killing the sources. Which means, there are two sources. One is current source, the other one is voltage source. If it is a current source, you have to make that open so that no current flows through it. And if it is a voltage source, you have to make that short so that no voltage will be available. Then you will be having remaining resistances. So find RTH from that. Then the third one is you need to draw Thevenin's equivalent circuit. So this one is Thevenin's equivalent circuit, which consists of a VTH in series with RTH. Then the fourth one is to find the load current IL. To find that, you have to add the load resistance. So already we found out VTH, RTH. Now add the load resistance RL here, so that the current flows through RL is named as IL. So from this you can easily find out what is IL by using Ohm's law. So what Ohm's law states? VTH by these two, RTH plus RL. So by this way, you can find the current through the load resistance using Thevenin's theorem. So I will just solve a simple problem to how to solve using Thevenin's theorem. So any resistance connected between the terminal A and B term to be the load RL. So in this one, 10 ohm is your RL. So following those four steps, we have to find the current flowing through RL, that is 10 ohm. So your step 1 will be to find VTH. So as I said, to find VTH, you have to first remove the RL. mark VTH. That is Thevenin's voltage. So now apply the loop current here and write the KVL equation. So you know it's minus 4I, then minus 6I, minus 12 and plus 10. That gives you, that is 0. From this, your I will be minus 0.2 ampere. If you solve this above equation, you will get I as minus 0.2 ampere. Now you have to consider this circuit. Here another current flows which always flows from A to B. That's your assumption. So here I am naming that current as Thevenin's current. So now you have to apply the loop current in this loop. And that loop current will be minus VTH plus 12 minus 6 ITH. So it consists of VTH, this 6 ohm and this 12 ohm. That's 0. And from this you have to equate ITH and I. So it is 0.2 equal to 0. From this your VTH will be 10.8 volt. So this is your first step to find VTH. Now your second step is to find RTH. As I told, RTH can be found out by killing the sources. Here two sources are available, both are voltage source. So you just make them short. To find RTH, you have to make the voltage sources short circuit. So just have this 4 ohm as such. This one is short and this 6 ohm. And in this place, you have to write RTH. Here you need to find the equivalent resistance. As you see, only two resistances are available and both are connected in parallel. So your RTH will be 4 into 6, right? 4 plus 6. This is the formula for connecting two resistors in parallel. So this gives you resistance of 2.4 ohms. So now step 1 and step 2 is over. Now step 3 will be drawing Thevenin's equivalent circuit. Your step 3 is to draw Thevenin's equivalent circuit. So Thevenin's equivalent circuit consists of VTH and RTH. So VTH in series with RTH. This is 2.4 ohm and this is 10.8 volt. And your final step, just add the load. So your IL formula is VTH by RTH plus RL. And your load value is 10 ohm. Just substitute in this 10.8 by 2.4 plus 10, which gives you a value of 0.8 ampere. So this is your final answer. So this is a very simple way to find the load current using the first theorem, that is Thevenin's theorem. Now we will see the second theorem, that is Norton's theorem, which is somewhat similar to Thevenin's theorem. Here also, any two terminal circuit can be replaced with a simple circuit consist of here instead of voltage, here it consists of current. Thevenin's current parallel to Norton's resistance. Norton's current parallel to Norton's resistance. This is Norton's equivalent circuit. Previously we saw Thevenin's where VTH in series with RTH. This one is Thevenin's equivalent circuit. So Norton's, instead of voltage you have current, that is Norton's current, which is parallel with Norton's resistance. So here also you have 4 steps. Step 1, you need to find IN. To find IN, what you have to do is just short the load. Short the load resistance RN. In the previous case, you have opened the resistance. Here you have to short the resistance. The second one is to find Norton's resistance. To find Norton's resistance and Thevenin's resistance, both are same. Just kill the sources. That means if it is a voltage source, make it short. If it is a current source, make it open. That's all. And find the equivalent resistance. And the third step is to draw Norton's equivalent circuit. That is Norton's current in parallel with Norton's resistance. And the fourth step is to find the current IL. Here the formula to find IL is Norton's current into Norton's voltage divided by, Norton's resistance divided by sum of Rn plus RL. So this is the formula to find the load current in the case of Norton's theorem. So you will see a simple problem to solve using Norton's theorem. You have a resistance 2 ohm in series with 10 volt, and then here you have RL of 5 ohm, and again you have one voltage source of 5 volt in series with a resistance of 4 ohm. So as I said you before, the resistance which is connected between A and B is your load. So here in this case, your 5 ohm is your load resistance. So what you need to find is, you need to find the current passing through this particular resistance. So follow the steps. Step 1. First step is to find Norton's current IN. For that, what you have to do is just short this load. Just take a wire and you have to connect between A and B. That is what means short load. So here we have assumed IN. So IN is flowing from A to B. So the direction is downwards direction. So you have 2 loops here. So first loop, I am assuming current I1. In the second loop, I am assuming current I2. So your total current IN will be summation of these two, I1 plus I2. Right? So what is I1? You know by Ohm's law, I equal to V by R. Similarly, this I also V by R. So here you have V1 as 10 volt divided by this resistance 2, plus here you have 5 volt divided by this resistance 4. So when you simplify this, you get a total current IN as 6.25 ampere. This is your first step to find IN. Your second step is to find RN, that is Norton's resistance. Here as you see, only 2 resistances are there, and between A A and B is your Rn. This is between A and B. And as you see here, two sources. Both the sources are voltage sources. So as I said before, to find Rn, you have to short the voltage source. So draw this resistance as such, and this, in the place of this, you just short. And similarly here, you short 5 volt and you draw the 4 ohm here. So now you can find the equivalent resistance Rn. So these two are connected in parallel. So substitute in the formula R1 into R2 by R1 plus R2. This is your R1 and this is your R2. Just substitute the values so that you will get Rn as 1.33 ohm. So this is how you will find Rn. Now your third step, draw the Norton's equivalent circuit. So this consists of In parallel to Rn. And your final step, step 4, is to find IL. To find IL, you have to add the load RL. So RL value is 5 ohm, RN value is 1.33 ohm, and IN value is 6.25 ampere. So now substitute in the formula. IN is IN into RN divided by RN plus RN. So you know all the values, IN value, RN value and RL value. This is RL. So substitute all the values so that you will get a final answer as 1.31 ampere. So this is how you will solve a DC, any complex DC circuit using Norton's theorem. Now comes the third one, maximum power transfer theorem. This theorem is somewhat similar to the first one, Thevenin's theorem. In Thevenin's, what you do? You find VTH, then you find RTH, then you will find a rod Thevenin's equivalent circuit, right? So here also you have to follow the first 3 steps of Thevenin's theorem. Just find VTH, RTH and then draw the Thevenin's equivalent circuit. But before that, I'll just tell you what is this maximum power transfer theorem. As the name says, maximum power transfer. So just consider a circuit with one resistance, a voltage source and the load resistance. So according to this theorem, the maximum power will be transferred from this voltage source to the load resistance when the internal resistance of the circuit is equal to the load resistance of the circuit. So under this condition, that is, the internal resistance of the circuit is equal to the load resistance of the circuit. Under this condition, the maximum power will be transferred from voltage source to the load. So when Rg is equal to RL, what is your total resistance here? As you see, these two are connected in series. So you just add these two, Rg plus RL. Since Rg is equal to RL, you can write this as 2 Rn. This is your total resistance. Now, IL is the one current which flows through Rn. How will you find IL here? Ohm's law, current equal to V by R. Here V is this Vg, R is the total resistance RT. So this gives you Vg by, already you have found out the value of RT, that is 2Rn. Okay. Now this theorem talks about power. So maximum power present in Rn. Formula you know, I square R. So this I is nothing but the load current I, and resistance is nothing but RL. Now substitute IL as Vg by 2RL here. So you get Vg by 2RL the whole square into RL. When you simplify this, you get Vg square by 4RL. This is the formula to find the maximum power P max, that is Vg square by 4RL. So what you have to do for this is just find VTH, then find RTH, then you draw the Thevenin's equivalent circuit, and then your fourth step will be this formula. Substitute P max equal to Vg square by 4RL. That's all. This is for maximum power. So under this theorem, we will solve one simple circuit. Just take down this one. Voltage, a source of 120 volt, connected in series with a resistance of 40 ohm, then another resistance of 20 ohm, and here another resistance of 60 ohm, and then comes the load resistance RL, which is connected between the terminals A and B. So for this problem, you won't get the value of RL because we already know RL is equal to Rg. Rg is nothing but RTH. So in your second step, you will be finding the value of RTH. So substitute that value for this RL. Okay. So we will see the first step. Your first step is to find VTH. For VTH, what you have to do? Just make this load open. Right? So just make this load open. And in that place, you mark VTH. So there is one closed loop here and another loop here. Now this closed circuit, you just assume current I is flowing through this. So apply KVL here. As you know, what is KVL? The algebraic sum of voltage across any closed loop is always 0. So the voltage across this 40 ohm will be written as 40I. So it is flowing from minus to plus, so it is minus 40I. Then 120 plus 120 and minus 20I, and it is always equal to 0. So from this 120 minus 60I equal to 0. From this I equal to 2 ampere. So this is the current flows through this closed circuit. Now you need to find the current flows through this. So I am assuming from A to B it is flowing, and that current I am naming that as Thevenin's current. So here also you just apply KVL. Since this is an open path, you have a resistance here, and you all know that current will not flow in open circuit. So this resistance is connected with the open circuit. So when you are writing KVL, just ignore this resistance because it is connected with the open side. So in open side, current will be 0. So just write for this and this. So you get equation of minus VTH minus 20 IPH equal to 0. When you are equating IPH with I, you get IPH is equal to I. So just substitute here as 2 minus VTH minus 20 into 2 equal to 0. So VTH will be equal to 40 volt. So this is your first step. And what's your second step? Just kill the sources and find out the equivalent resistance. For that, what you have to do is, you just do it here itself. Since it is a voltage source, you just make this short resistance, leave this resistance as well. And here, in the place of A and B, just mark RTH. So now what you have to do is find out the equivalent resistance. So these two, as you know, it is connected in parallel. So the formula is 40 into 20 by 40 plus 20. So this resistance is connected in series with 60. So just add 60. So this gives you the equivalent resistance. Here it is called RTH. So when you solve this, you get a value of 73.33 ohm. Okay. Now what's your third step? Just draw Thevenin's equivalent circuit. So Thevenin's equivalent circuit consists of VTH in series with RTH. So here only one which varies from Thevenin's is this formula, P max. So maximum power transfer to the load is given by the formula Vg. Here is nothing but VTH. So VTH square divided by 4 into RL. But in the problem, RL value is not given. But I told RL is equal to RTH. So substitute in the place of RL, you substitute 73.33. So VTH, we got it as 40 divided by 4 into 73.33, which gives you a value of 5.45. So since it is a power, unit is watt. So this is your final answer. So if you know Thevenin's theorem, you can easily solve for maximum power transfer also. Now the final theorem, that is superposition theorem. So this is also very simple. Superposition theorem. So far we have seen the three theorems: Thevenin's, Norton's and maximum power transfer. So in those theorems, it doesn't matter whether you have one source or two sources. But whereas in superposition, this can be applied to the circuits which consist of more than one source. It could be either voltage source or a current source, it doesn't matter. But it should have more than one source. So it states that the algebraic sum of the current flowing through any branch is equal to the sum of all the currents flowing through that branch when you are considering only one source at a time. Considering only one source. So this will be easily understood if we solve one problem here. So let us see one problem. So here I have taken one current source and one voltage source. This is the current source of 20 ampere and this one is a voltage source of 200 volts. Okay. So as here there are two sources available. One is the voltage source, the other one is the current source. So superposition theorem, you can solve it when you have more than one source. So here, first consider any one source at a time. So I am going to consider the voltage source. So what I have to do with current source is, since it is a current source, you just make this open. Now see the circuit, you have only one voltage source. So in this, you need to find the current through 23 ohm. That is our aim. You have to find the current through 23 ohm. So how do you find the current through 23 ohm here? You know by Ohm's law, current is equal to V by R. Right? So you know V value. What is V value here? 200. R you need to find. So there are 4 resistances here connected in series and parallel. Just find the equivalent resistance. That gives you the value of R. So R equivalent will be, just say these two, 47. These two are connected in parallel. So substitute in the formula R1 R2 by R1 plus R2. These two are connected in parallel, right? And how about these two? These two are connected in series, right? So when you solve R equivalent for this, you get R equivalent as 60.5 ohm. They are connected in series and parallel. Just simplify that. You get a value of 60.5 ohm. So your total current is 200 volt, right? Fine. But what's your aim? You need to find the value of this IL. So IL formula is the total current into, which is the opposite resistance of this. For this, which is the opposite resistance? This one, 27. Divided by 27 plus, these two are in series, so you add these two, 4 plus 23. So what is your I? I is V by R. Total voltage is 200. Equivalent resistance is 60.5. So when you solve this, you get a current of 3.306 ampere. Right? So that is your total current. 3.306 into 27 by 27 plus 27. This gives you a value of 1.65 ampere. This is the current flowing through this particular resistance. So this is named as IL dash. That is the current through 23 ohm when you are considering only one source. That is here the voltage source 200 volt. Okay. Now you need to find the current flowing through the same resistor when you are considering the current source 20 ampere. So this is the voltage source. So you make this as short. Right? Now you need to find the same current flowing through 23 ohm but with a different source. Here what you have to find is, you can directly do this. IL double dash is equal to, what is the total current? Here you need not find total current. Already given here itself, 20 ampere. So 20 into, which is the opposite resistance. For this 23 ohm, these are all the opposite resistance. So the value is, for this is 21.2 divided by 23 plus 21.2. This gives you a value of 9.6 ampere. This is your current flowing through 23 ohm when you are considering the second source. And this one is the current through 23 ohm when you have considered the first source. Now the overall current IL, that is the algebraic sum of individual currents, that is IL dash plus IL double dash. This is what superposition theorem states. So the current flowing through any branch is equal to the algebraic sum of individual currents when you are considering any one source at a time. So we have considered one voltage source at a time and we found out IN. Then we have considered the another source and found out IN double dash. Now we have to add those two, algebraic summation. So 1.65 plus 9.6, which gives you a total of 11.2 ampere. So this is your final current which is flowing through this particular resistance 23 ohm. So with this, all the four theorems have been completed.